This conference will now.
Okay, so good morning, all, and welcome back to the session. This is Big Data Masters program. So we are going through with distributed computing with PySpark, and from the PySpark perspective, we have seen RDDs, and we have performed certain operations on RDDs. So RDDs are nothing but in-memory distributed collection of elements, and they are having the benefit of distributed computing because, if you are going to create a particular RDD, so that will be available among different machines, and you will be able to, you can say, work on to top of that particular RDD, and it is giving us the outcome, and it is having certain, you can say, properties like say lazy evaluation and fault tolerance. Okay, so lazy evaluation means until unless you are not performing any operation action onto top of RD, nothing will be executed. It is completely lazy in nature. Okay, it is going to take all the transformations, and until unless like we are uh, till we are applying transformation, nothing will be performed. And we need to take action in order to get the outcome, and then the spark will work onto that particular RDD. And RDDs are nothing but lower level construct inside the PySpark. These are lower level construct. So today we are going to discuss about deployment mode. Deployment mode, what are the different deployment mode basically? So in PySpark, we are having two types of deployment mode. First one is client mode, and second one is cluster mode. So what is the basic difference between both of these two modes? Like, if we are able to see inside the client mode, the driver is running, the driver is available inside towards the client side. It is available inside the client machine. Once we are having cluster mode, the driver is running inside the cluster. In order to have detailed discussion about this particular topic, let me try to give you certain insight about the yana. So distributed computing with Spark, and let me create a notepad. D30, okay, so what was there? We are talking about distributed computing. Distributed computing. And with respect to the distributed computing, in Hadoop is also like a framework which is utilizing distributed computing, and it is having, say, master and slave. Hadoop is having master and slave machine. Slave 1, slave 2, slave 3, slave 4. Slave 4. Say we are having this 4 node cluster. And these slave machines are nothing but data nodes. Let me mention data node 1, data node 2, data node 3, and data node 4. Try to focus onto this particular topic, that is more important. That is very important because, like, this particular topic is going to provide you the base, uh, how the resource management is happening inside the PySpark world. And this is nothing but name node. So name node is there. So like, if we are able to see this particular diagram, or not diagram, but like master and slave configuration, say one master node is there and it is having multiple data node. Now if a client is coming, the client is having will have discussion with the master node or name node, and he will say like, hey master node, I want to perform certain operation, and please provide your go ahead in order to perform that particular operation. So that particular name node will perform two activities. So with respect to an application, there are two basic activities, like scheduling of job and monitoring of job. So the client came to master node, and he asked certain resources, or he said like, I want to perform execute this particular application. Then based upon the resource availability, master node is not performing any like operation onto top of the data. He's just like aligning certain data nodes in order to perform that particular task. These are the actual, you can say, performer, or you can say the end task is performed onto these particular machines. So that is nothing but scheduling of a job. Scheduling, like, it is going to assign machines in order to perform that particular task, like which is given by a particular client. Client. So the client request to this, and based upon the available resources, this is going to schedule, or it is going to provide those particular resources. But the next thing what is there, like monitoring of the job. So once the application is coming in execution state, another task that is performed by this master node, we are having a job tracker. Job tracker over here, known as JT, which is running onto the master node. Over here we are having onto the slave machine task tracker, TT. Okay, task tracker, these are performing the task, and JT, job tracker, this is, you can say, scheduling and monitoring that particular job. That is fine. So scheduling of job, that is fine, like aligning the resources based upon the availability, and then it is given to task tracker, and tracker is going to perform the task. Now this is the duty of this job tracker in order to monitor that particular job. So monitoring is also done by this particular machine. Now there is a challenge. Okay, this particular job tracker is not able to perform its job in a good way once the load is increased, or once we are having a cluster greater than 4000 node. Cluster greater than 4000 nodes, then there, that is a bottleneck. That is a bottleneck in Hadoop 1. We are talking about Hadoop 1. So inside Hadoop 1, once the cluster size increased more than 4000 node, it is not able to monitor those particular jobs, because over here this is the only person who is going to monitor all of the jobs which are running inside the cluster. Say we are having 10,000 clients, and all the 10,000 jobs he needs to monitor onto this particular cluster. So this is the failure point or bottleneck. If the cluster size is increased greater than 4000 node, this, you can say, job tracker is not able to manage, it is not able to monitor, and the performance was impacted at that particular time. Another thing that is available, say scheduling, this is the only person, like say, which is performing the monitoring and all. So uh, so it is like, it is having a lot of, you can say, task to perform, like monitoring and all. And then if the new jobs are coming, the if like it is busy in monitoring, then scheduling is not proper, will not be proper in that particular case, huh? So that is the failure point in Hadoop 1. Then Hadoop 2 came into the picture, huh? Hadoop 2. So Hadoop 2. Hadoop 2. Okay. So what is there in Hadoop 2? Let me show you certain diagrams as well. Okay. So this is the stuff what I was talking about. Okay, so this was the job tracker, and this particular job tracker needs to monitor all the jobs. And if the cluster size is greater than, you can say 4,000 nodes, over here, like what you are able to see, 4,000 task tracker. 4,000 task tracker means like we are having 4,000 node cluster over here, and task tracker is available inside the data node only. So that is the failure point, huh? Now what is there with respect to the Hadoop 2? Then Hadoop 2 came into the picture, huh? So inside the Hadoop 2, what we are having resource manager, huh? Resource manager, and say node manager, huh? Node manager, resource manager, that is available inside the name node only. Okay, name node, that is the master machine, and node manager, that is nothing but that is available onto the data node. So resource manager and node manager, these are the two, you can say, component in place of, you can say, job tracker and task tracker. Okay, this was, you can say, acting this was like a task tracker in Hadoop 1. Over here it is known as, say, node manager, onto the available onto the data node. So over here it is known as, say, resource manager, and available onto the, say, master machine. Now what is happening over here, so w- now what, like if a client is coming and client want to run a particular application, so he's going to contact to the resource manager. Same like in the Hadoop one, we were communicating with, say, name node, that is nothing but the master of the cluster, so he will discuss, hey resource manager, I want to perform the execution of a particular application. So this particular resource manager, what it will do, it is going to start an application master into one of the node manager. So one, that is node manager, nothing but the data node only. Okay, inside a particular data node, he's going to run a particular container, and in that particular container, application master is there. Application master. So the container over here, if you are able to see the container is nothing but the combination of certain memory and core, like certain hardware is blocked in order to run application master. So that is the second step. The resource manager is going to initiate application master. Now this application master will check this particular application, which the client wants to run onto the cluster. Then Based upon the application master start negotiating resources to the resource manager. He will ask, hey resource manager, this application, for the execution of this particular application, I want this much resources. So resource manager is having the entire information about the cluster, like how much applications are there, how many applications are there, and what is the what are the different non-occupied resources. So based upon his request, he is going to provide those particular resources to the application master, and application master allocate those particular resources to that particular application, and it is like going to, you can say, reserve certain container and container into the node manager, and the execution will start. So one change which has happened over here, now this application master will start monitoring of that particular job. Okay, this particular application master will start the monitoring of that particular job, and once the job is completed, it is going to inform the client. Now the load of the name node, or you can say master machine, has been reduced. The main task that this resource manager is going to perform, that is scheduling of the resources only. Monitoring is done by application master only. Like if we are having thousands of applications which will run inside the cluster, then we will have thousands of application master, those will monitor that particular application. Okay, that change was done inside Hadoop too, and that is known as Yarn, yet another resource navigator. Okay, so over here, what we are able to see, the issue which was there, that was like uh, once the cluster size increased greater than 4000 node, the Hadoop was failed. But now with the addition of, you can say, resource manager, application master, and node manager, that particular bottleneck has been, you can say, resolved. And now like if the node size is greater than 4000 node, that is not a bottleneck inside the Hadoop too. Okay, so same concept is utilized inside the Spark as well. We know it very well. Spark is having different, you can say, resource managers, say Yarn, Mesos, Kubernetes, and standalone, Spark standalone. Spark can have these particular resource managers in order to manage resources among the cluster. So how the things are happening with respect to these particular resource manager. So let me take an example with Yarn. So same stuff like what we have seen in the big data or Hadoop world. So same concept will be applied over here once we are using Yarn as a resource manager for Spark job or PySpark jobs. So just have a look onto this particular diagram. Okay, so what we are able to see over here, we are having Yarn as a resource manager. In both of the case, either it is the client mode or the cluster mode. In both of the cases, we are having Yarn as a cluster manager. Now, and we just need to differentiate what is the what is there in client mode and what is there in cluster mode. Now the same stuff, like client is there and client wants to perform the execution of a particular job. This is the, you can say, Spark cluster. This is Spark cluster. Now the driver, the client is going to request to Yarn manager, and Yarn manager like yarn manager or RM is going to initiate an application master in one of the node manager. That is fine. Okay, it is going to initiate the application master in both of the cases. Like the application master is reserved, or you can say initiated, in one of the node manager. An application master is nothing but who is going to, you can say, who is going to bargain resources with resource manager, and that is nothing but the combination of, you can say, certain hardware, memory and core. So that is reserved for this particular application. Now the main difference between both of these two approaches, like the driver is nothing but the master of the Spark cluster. Okay, so this driver program, once it is, you can say, initiated, okay, once it is running inside the client machine, once it is running inside the client machine, that is the, you can say, client mode. And once this particular driver program is initiated inside the inside the Spark cluster, that will be the cluster mode. So over here, this is the cluster mode what we are able to see. So the client is coming, he's going to he's going to, like, discuss, say, hey, yarn manager, hey Jan, hey resource manager, hey Jan, I just want to perform certain execution of certain application. Then it is going to initiate the application master. Okay, so once the application master is initiated, then it is going to bargain the resources. And once, like, it is having the information of resources, then it is going to, you can say, start the executors. Okay, yarn container or executor, that is nothing but, like, it is providing certain resources to that particular application in order to have the execution. And then, like, it is, you can say, the driver is there, and it is driver is going to, you can say, check the functionality about that particular job. And once the job is over, it is going to inform to the client, like the job has been executed. Once it is there, like, inside the client mode, that is with respect to the cluster mode. Once we are having client mode, so same stuff is happening over here, like, except one. Over here, the first, like, the client is coming and it is going to discuss with Jan, like, I want to do the execution of this particular job. Then application master will be, you can say, initiated. Then it is going to get the information about available resources and provide those resources to that particular job. And now this particular, you can say, driver which is running at the client and which directly monitor the execution of those particular application. And once the execution is done, like, at the driver end, the client got the information, and uh, like, say, the job has been executed or not. But there is one challenge in this particular approach. If, like, there is certain issue inside the client, uh, client's laptop or client's work machine, and if that is down because of any reason, entire cluster, like entire execution of the job, that will be lost. If over here, if, like, something is lost, if the driver connectivity has been lost, but there will not be any impact onto the execution of that particular job. And say the driver, say the client wants to get the outcome, once, like, the outcome will be stored onto the S3 location. S3 is nothing but a bucket from the, you can say, AWS side, in order to, or you can say, data lake, to store certain data. Okay, so that will be, like, keep on executing on the back end, and after the execution, it will be, like, outcome will be moved on to the S3. But in this particular case, if the client machine is having certain issues and the connectivity or the driver program lost, entire you can say functionality will not be able to track, and that will be the that will we can say that is nothing but the cluster failure. We will not be able to perform that particular task. So that is challenge, and inside the production environment cluster mode is being preferred because like things will be executed onto the cluster, and I don't like we don't want to be dependent onto the client machine. So that is nothing but like client mode and cluster mode what we are having inside the world of PySpark. Just have a look and ask if you are having any doubt. Just have a look onto these particular things and ask if you are having any doubt. Vandana, Swati, Shivam, Rohit, Rajbabu, Rahul, any doubt onto client mode and cluster mode? Anything that you are not able to understand? Shivam, guys, try to be interactive.
No, sir, it's okay.
That's fine. Okay. What about Shivam, Rajbabu, Swati, Vandana, and Rahul?
Yes, sir, Raj Babu. No, sir, it's okay.
Okay, that is fine. Now, so we have seen driver. Inside that particular diagram, we have seen driver. So driver is there. Driver. So what are the different responsibilities of driver? Of driver. So it is going to schedule task and control their executions. Schedule task and control their execution. That is the first responsibility. Yeah. Then we know Spark context with respect to the already Spark context, that is the entry point for Spark 1. So Spark context is created by this by driver. That is fine. Now it is going to store the it is storing metadata about RDDs and their partition. So schedule task and control their execution. Spark context, that is the entry point and for the RDDs in Spark world. So that is created by driver only. And like the metadata with respect to the RDDs and the partition information that is maintained by this particular driver program. Okay. So what we have seen now, RTDs. We were discussing about RTDs. This is a like the basic stuff in order to have the deployment of a particular Spark applications and how the things are happening at the back end that we have discussed, like the resource management stuff, what is being happening in PySpark. Now we were discussing about the RDs. With respect to the RDs, we have applied certain actions and transformations. Actions and transformation. And with respect to, you can say, transformation, like we are having two types of transformation: narrow transformation and wide transformation. Narrow transformations and wide transformation. Now, what is narrow transformation? Like when there is no shuffling of records. Those are called narrow transformations. Once there is shuffling of record, once there is shuffling of records among executors, among nodes, we can say, among different nodes, then we can say, then that is wide transformation. So the transformation, say map, okay, flat map, filter, okay. So these are nothing but you can say narrow transformation. Narrow transformation examples. Wide transformation, narrow, then wide. These transformations we have seen. Okay. So reduce by key, reduce by key, group by key, join, distinct, uh, intersection, subtract. So these are nothing but wide transformations: union, departition, police. Okay, so we are going to learn these particular transformation as well. Wide transformation, wide transformation. Just a minute. So you just need to write a program for me And just you need to utilize the filter transformation. What we are having, say we are having data, write a program. Let me, you need to write a program for me, right? A program for me. You are having a data, or you are having a list basically, and that is having certain data. Say 1, 2, 1, 2, 3, 5, 6, 9, 10, 23, 45, 1, 4. Okay, so we are having this particular data. So what I want, I want to have the even numbers only. Provide even numbers only from this particular list. Okay, just write a program and share the outcome with me. Like share the code with me. Outcome you will be able to share, and tell me the approach how you are going to tackle this particular problem. You just need to utilize filter transformation, and filter transformation with, you can say, lambda expression. Okay, and first of all you need to create a RTD onto top of this particular data. This is list, so you need to utilize sc.parallelize in order to make a RTD. Once you are having the RTD, then you need to utilize the filter transformation. So just write down the code for me, all of you. Let me share this particular data. Okay, so write down the code for me, all of you. Is problem statement clear? Shivam, Vandana, Swati,
Yes.
Rajbabu, Rohit, Rahul.
Yes, sir, it's fine.
Okay, okay. Okay, so I think from the RTD perspective, that is more than enough, and we can have like certain other programs as well onto the RTDs. Uh, but the main topic or main most important stuff from the Spark side, that is the easiest one as well. That is nothing but the data frame, and in these days data frames are mostly utilized. RTDs are, you can say, utilized for certain cases. Okay, but there are certain issues with RTDs as well. So what are the different things that is there with respect to RTD and data frame that we are going to see? So so RD and data frame. RD, like we have seen RDs, now data frame. Data frame. RDs are nothing but schema-less distributed collection of elements. Collection of elements. But once we impose the schema, or like how we can code, how we can code in PySpark. So there are four, you can say, methodology in order to code uh, in PySpark. So first one is RD that we have seen, and these are nothing but a schema-less distributed collection of elements. So we can differentiate based upon the batch processing and say streaming processing. Streaming processing. Batch processing, like we are dealing with batch jobs over here. As streaming processing, like we are going to create uh, the you can say RDs or data frame of small size, or that will be of, you can say, very short duration, and we will feel like the execution is happening in real time only, but that is not the real time execution, that is near real time. And over here we are handling or dealing with the streaming data. Okay, streaming data processing or batch data processing, these are the two, you can say, uh, methodology in order to process the data with PySpark. So already schema-less distributed collection of elements and data frame. When we impose schema, then a schema on already, say schema on already, then it will become data frame. Data frame. So data frames are providing a certain betterment. We will see those particular things. But like, what are the other, you can say, way of coding with, or approaches with the help of those we can do the data processing? So first one is batch, and RDs and data frames are the two approaches by which we can work with PySpark. Third one, like what we are having, Spark and streaming, and last one is Spark structure streaming. So once we are using RD, once we are using RD to process streaming data, then that is Spark streaming. Spark streaming. And over here, like, say what we are doing over here, we are imposing, with respect to the data frame, we are imposing a schema onto top of RD. So same thing is replicated over here. Once we are using data frame, and data frame is nothing but like RD with imposed structure, RD with imposed structure. So once we are doing the processing with data frame and handling streaming data, or you can say data frame for streaming data, that is nothing but Spark structure streaming. Okay, structure streaming. Now we are like, first we are going to discuss with batch, with respect to the batch processing, and say we have seen RD, and we are having data frames as well. Data frames. So what is the difference between data frames and RD, and what is the betterment that is given by data frame, or what is the positive point inside the RD side, that we are going to see with the differences. So like if we talk about version, say version, so before, you can say 1.3, RDs were available, and you can say inside Spark 1 RD was there, and after, you can say Spark 1.3, post 1.3, Spark version, basically Spark version 1.3. These data frames are available. Okay, so you can say these are the latest, you can latest stuff in order to code with PySpark. Then we are having what say lazy evaluation. So say lazy. So both of these, you can say RD and data frames are providing lazy evaluation. That is fine. So inside, as we know that Spark itself is lazily evaluated, and until unless like we are not taking any action, nothing will be performed onto the Spark data. So both are having lazy evaluation. Then optimization, with respect to the optimization. So no built-in engine for optimization. Engine for optimization. I'm mentioning opti only. And over here we are having catalyst optimizer. Optimizer for optimization. So just let me show you the diagram of catalyst optimizer. Catalyst optimizer in Spark. And I want to show you the images. Hmm. So just have a look onto this particular diagram. Catalyst optimizer. We can take this particular diagram. We can take any diagram. So catalyst optimizer. So what is there with respect to catalyst optimizer? Like say if we are having certain Hive queries, if we are having data frames or SQL queries, then like it is going to passed with these particular queries will be passed with certain steps, and at the end we are getting the RD. So whatever like we are going to perform, whatever we are going to execute with PySpark, that will be, you can say, executed in terms of RDs only. But RDs, that is nothing but the Spark core. No? Execution is done onto the Spark core. But like on to the RTDs, if you are having something in terms of RTDs, then these particular optimized steps are not there in RTD, and that is nothing but catalyst optimizer. So what is there with respect to the catalyst optimizer? So the queries that you are having, that is going to like pass with certain rules. So first one is say analysis rule. Over here it is going to analyze your query with respect to certain syntax error and all. Okay, once that particular, you can say, those particular errors have been checked, then it is going to map it with the schema and convert it into the logical plan. And once like it is converted into the logical plan, then it is Spark is going to perform certain optimization onto top of your query, and you will get the optimized logical plan. Okay, so yeah, over here you will be having a lot of strategy in order to convert optimized plan into physical plan. And your query will be converted into multiple physical plans. Physical plans say all of the plans will have different cost. So different cost, then it is going to pass from the cost model, and the plan which is having the least cost, that will be selected, and it is converted into the RD. So cost over here, that is nothing but latency. Okay, so latency, based upon the latency, like optimized plan is converted into the multiple physical plans, and those particular plans will have different cost. So that is nothing but a catalyst optimizer inside the Spark, and data frames are having the benefit of catalyst optimizer, or we can say sometimes tungsten engine. Okay, so data frames are the most, you can say, optimized flavor from the Spark side, and we are having optimization with the help of catalyst optimizer. Now, another you can say difference, say what I can say, schema. Okay, schema. So no schema is available over here. Schema is available. Is available. So that is the fourth difference what we are having. Then what I can say, ease of use. Use. So with respect to, like, these are the lower level API. And what I have mentioned, this is the most toughest part. Like if you are able to understand RDs, then you have understood the most toughest part from the Spark side. And from the data frame perspective, these are the, you can say, higher order API, and these are the easiest one as well. Higher order API, easy to learn, most easy to learn and understand. You will see and you will feel this particular stuff as well. Like in order to utilize, in order to use data frame, that is more easy. And we have gone through with our Python journey as well. So you will feel like you are working with, you can say, Python related stuff. So the journey will become very easy. So ease of use. Then community support. So support, not support. So community support. So over here, less support is there, because like these are the older, you can say, component from the Spark. So nowadays, community is utilizing data frames. So data frames are having highest, you can say, community support, higher community support. Now, performance, we can with respect to the performance, say, like from the RTD perspective, so performance, like these are not having the benefit of catalyst optimizer. Internal optimization is not there. So these are, you can say, having, say, low performance, and these are having much higher performance or much good performance compared to RD. Okay, so data frames are providing good performance if we are going to compare it with RD. So these are the basic differences what we are able to, you can say, see between RD and data frames. Now, like in RD, the entry point, the entry point. Okay, we can mention over here as well, entry point. Entry point, that is Spark context, and over here we are having Spark session. Spark session. Okay, so in RTD the entry point was Spark context, but in data frame, but in data frame the entry point is Spark session. Spark session. So the difference, like between Spark session and Spark context, that is like Spark session is available after, say, 1.3. These are this is available for, you can say, data frames. And another difference between Spark context and Spark session is, like, once we are utilizing Spark context, then we need to have different Spark context for each application. Like if you are utilizing Hive, then you need to have Hive context. If you are working with SQL, then you need to have SQL context. Okay, so for each and every application,
कपड़ा
you need to,
एक रखा तो था खुला कपड़ा
guys, please go on mute. Please go on mute. Mhm. So for different, you can say applications, we are having different Spark context, but Spark session is an umbrella which is containing multiple Spark contexts within it. So there is no need to, you can say, define multiple context in order to deal with multiple uh, sources, say Hive or SQL. So Spark session is able to handle all of those particular stuff. Now, how to create Spark session? How to create Spark session? How to create Spark session? So, in order to create Spark session, what we need to have, we need to import certain and like libraries from the Spark side, from pyspark .sql import Spark session. We need to import this because like we are going to work with IDE, so we need to create the Spark session. If you are working onto the command prompt, then Spark session is already available over there. Let me show you PySpark. So over here, friends, if you are able to see Spark session available as Spark. So this session is already available over here. We just need to utilize it in order to code. Uh, but ID, this is, you can say, external ID that what we are having. So for this particular ID, what we need to do, we need to create the Spark session by ourselves. Data frame 1. Okay, so how we can create, say, from pyspark.sql import Spark session. Okay, so Spark session has been imported. Now, what we need to do, we need to create the Spark session. So then what we need to say, we can create Spark and Spark session dot builder. We need to utilize this particular, you can say, import Spark session dot builder. We are going to build uh, the Spark session over here. Okay, builder dot, we are going to give an app name. You can give any app name over here, say first Spark program, first data frame program dot get or create. Okay, so this is the stuff, like the simple way in order to create the Spark session. Spark session dot builder dot app name first data frame program get or create. Okay, so like we have created the Spark session. Now we can leverage this particular session in order to work. So say the first thing, like say I want to read certain data. Okay, reading data with PySpark. So for inside the PySpark world, what we are having, we are going to perform three operations only. Like we are reading data. Then what we are doing onto the second phase, we are processing that particular data, processing data. And the last phase, what it will be, like writing the output, writing the output. These writing the output, it doesn't mean like we are going to write it onto disk. We can like club it with certain business visualization tool or business intelligence tool. We can apply certain machine learning algorithm. So over here you can say club it with business intelligence tool, say Power BI, then prepare certain dashboard, and that will be, we can say, happening onto the processed data only. So these are the three, you can say, steps in each and every program in PySpark world. First we are going to read the data. Second, like we are going to process that particular data. Third, like we are going to write that particular data. Okay, so reading the data. So inside the PySpark world, we are having standard data read API. Okay, standard data read API. So standard data read API, let me check a particular file that I can read. Let me try to map a schema over here now. With schema. So with schema, let me convert it in CSV format. It is with schema, and let me give the schema as well. Say ID and say product ID and say price for amount. Say this one is the customer's order with schema. This is the file that I'm going to leverage. Now, what I have mentioned, like I'm going to read this particular file. I'm going to leverage standard data read API. Yeah. So this is the path what I'm having. Let me mention this particular path. Processing data with Spark. So space is there now over here. So let me copy this particular data over here, and the file name is this one, and this is nothing but CSV file .csv. .csv, and this is the path of that particular file. And in Spark, like I need to read in this particular way, that is fine. Okay, so this is the path. And once like I am going to read a particular data, so what I'm having, a standard data read API. So say customer data that I'm going to read, this will be the data frame name, say spark.read. I am going to leverage a read. Okay, and say dot uh, format. Which format I want to read the data? Say CSV format. CSV format. That is fine. Okay. So option like, do I want to is like that particular data is having header information, is having header information or not. So header is there. We have just defined header, and I can mention, say header is true. That is fine. Now what I can have, like, option schema, infer schema, infer schema. So infer schema I can take, say true as well, true. Then what I can have, option and mode, in which mode I want to read this particular data, mode. And we are having multiple mode, say permissive, permissive. That is fine. Dot option, and I guess I'm going to mention the path as well. Option and path of that particular file, and I'm going to copy that particular path. Say this one is the path, and dot load. So this is nothing but standard data read API for each and every file. Now whatever you are having, say if you are having the JSON file, you just need to like mention JSON format over here, format, and you can replace the CSV with JSON. If that particular file is having header information, is not having header information, then you can remove this particular clause option. If like you are going to leverage pyspark to you can say define the schema of your data, then you can say set this particular clause, option infer schema true. Okay, there are certain modes. I will walk you through with those particular modes as well, but just have a look what is happening once we are reading the data with this particular standard data read API. Let me paste the stuff over here, and need to leverage this one. So I'm just doing the formatting so it will look good. Okay, so what I have mentioned, like we are having different modes, then I have mentioned the path, and this is the path. So what you just need to do, you just need to change these particular parameters with respect to your data, and you will be able to read that particular data. And what we are having, a customer data dot show, and show is going to list top 20 records from this particular data set. Let me run it. So why I am calling this standard data read API, because you just need to like change certain parameters, and like it will be acting as a standard. Like if format is there, so different format is there, you just need to mention that format. So what is saying, option, spelling mistake, option. So option, that is fine. Let me run it once again. So spell mistake was there. You just need to change these particular parameter, and you will be able to read. And that's why like this is called the standard data read API. Okay, and just have a look. So what we are able to see, we are able to get the data in tabular format, and it is having say hidden information as well. Product ID, amount, each and everything is there. And let me try to print the schema as well. Customer data dot print schema. Okay, so let me print the schema as well. We will see like over here we are leveraging this Spark Beauty in order to infer the schema, or Spark functionality in order to infer the schema. But we can define the schema of data set that we are having two other methods as well in order to define the schema. Okay, so I will walk you through with respect to that as well, but at this moment we are going through with the standard data read API. So the root like ID is of integer type, product ID integer type, and amount is of double type. So what is happening over here, Spark is smart enough, it is going to like check the data, and based upon the data that you are having, it is going to define the schema. Schema is like the data type with respect to each and every field. Like ID, it has seen, the Spark has seen the data, like this is of integer type, so it has given integer as a data type to this particular column. ID, that is nothing but this particular column. The product ID, that is the second one, and it has defined it as an integer. Then amount, amount is the third column that we are having, and it is defining it as integer. So this is like the Spark functionality that we have leveraged over here. Now mode, so we are having four different modes. Read modes, infer schema, let me first mention. So infer schema, so we can define like defining schema in PySpark. So first one is infer schema, second one is say second one is programmatically define schema. Third one is with DDL string. Okay, so these are the three methods in order to have schema of your data. Okay, I will be covering all of these particular methods. We have seen like infer schema, we are leveraging the Spark functionality in order to define the schema, but that is not preferred one. We are going to have our own schema, and these are two approaches. I will show you how you will be able to define. Then the mode. So in Spark, we are having different modes in order to read the data. Okay, different read modes. Read mode. Number one is say permissive. This is say default mode. If nothing is defined, then this mode will be taken, and it is going to load the data, data, load the data. If errors are there, if errors are there with respect to data format. I will show you format. Then second one is fail fast, drop malformed, and error. These are the four data read mode. Fail fast. So if errors are there, then the job will be failed. Drop malformed. If errors are there in data, then it is going to drop the mal records or the records which are having error. It is, if errors are there, then it is dropping those errors and read the the data. And error, like this particular mode, it will throw error. It will throw errors if data is having small records. Okay, so these are nothing but with respect to the parameters that we have used in this particular standard data read API. Okay, so just try to leverage this particular standard data read API and tell me, are you able to read the data? Just try to leverage this particular API and confirm, are you able to read the data or not. Swati, Rahul, Shivam, Vandana, Rohit, Rajbabu, try to first define the Spark session and read a particular file with the help of this standard data read API from Spark or PySpark. And this is very like easy as well. So previously, once we were dealing with RDs, then like we need to remember, we need to apply different, you can say, transformations and all in order to have the data in right format. But over here, like if we are having data in CSV format, we just read it and we will be able to work onto that particular data. If you just want to perform the operations onto a particular column, you just select that particular column. We will be going through those particular operations in detail, but first try to read the data, then we will try to see different data read modes. Okay, and I will walk you with the differences what is there with respect to each and every mode. Try to read it and confirm. You might be having a particular file in your machine. At this moment, try to use CSV file only. If you are working, if you are willing to work with uh, Excel file, then there are certain other steps, like there are two steps. Either we need to like first utilize the pandas. We are going to we read it first with pandas and convert it into the pyspark data frame. Second is like we need to have certain properties that we need to like, or package, we need to have certain packages that we need to install, and then we will be able to work with the excel data or excel files. Okay, CSV, like we are having direct support and we will be able to read the CSV file directly. There will not be any issue. Try to read this particular a particular file which you are having, CSV file you can take. Okay, and confirm like are you able to read it, and meanwhile, hmm. Please provide your confirmation. Are you able to read a particular file with standard data read API?
Yes, Ashok, running for me. It's working.
Okay, perfect. What about others?
And one query here, Ashok.
Hmm?
So this header in first schema, so there is no issue for any sequence. We can put a header first and then in first schema after that one. So there is no
Okay, okay. You
fixed
want to
sequence.
say like options, huh?
Right. So
Like
is
if
there
you
any
are,
sequence?
yeah, no, no, not an issue. You can put it in any format. Any, you can say order,
Okay.
not format.
Yeah.
Like option can be over here. Okay, like permissive will be after this format and all, right? So ordering is not will not create any problem. Now, another thing that you need to do over here, we have utilized a permissive mode. Permissive, that is nothing but like if certain errors are there, that particular data will be read, and there will not be an issue. But if certain we are leveraging any other mode, what is happening if the data set is having certain errors? So I have shared you one file, that is players.json file. Now what you need to do, you need to leverage different modes, say fail fast, drop malformed and error. Then you need to tell me what is the difference between each one of them. Like once you are leveraging drop malformed, then what is the outcome that you are getting from the players.json file? And if like we are using if you are using error mode, then what is the outcome that you are getting? You just need to read that particular file players.json and tell me like what is happening into different modes. Is problem statement clear? We just need to leverage, we just need to get the understanding about these particular mode with the help of players.json file. I have shared it onto the batch 26 WhatsApp channel. So WhatsApp group, you can download it from there and import it and tell me like what is happening, what is the outcome that you are getting with respect to each and every mode. So we are going to understand what is happening into different modes, different read modes.
So need to simply run this file or some need to change here in the code.
You just need to like change the path. You need to download that particular file what I have shared, and you just need to change these particular mode. Like over here I have utilized permissive, then you need to change permissive to drop malformed, then what is the outcome that you are getting? Okay, drop malformed, permissive, fail first, error. So you just need to share the outcome with each and every mode. Clear, Rohit?
Yes, just give those different options that we need. Drop mall, what is the full syntax that will drop exact wording for it.
Permissive fail first drop malformed and error.
Okay.
These are four
Okay.
different modes.
Got it.
Rahul, Rajbabu, Shivam, Vandana, are you working onto the problem statement? Huh?
Yes, sir. But
Sir, it is giving error.
Which mode you are utilizing? Share the error onto
PSP.
the share the code and error.
Ashok, I ran all four and I'm getting error only in fail fast. In rest of all, I'm getting the output. See like this.
This is with respect to permissive. Huh?
Uh, Only I'm getting error in fail fast. Rest all I'm getting the same output in the file log.
No,
I
no,
am
no.
getting the
Output
data.
will not be same. Huh? Output will not be same. You just need to understand. Huh? Okay. So let me do it for you. Just have a look. So this is player.json and the format is JSON. Huh? Okay.
Yes.
And now what I'm going to leave is permissive. So what is happening in permissive mode? Huh? I'm reading players.json file. The format is JSON and the mode is permissive. Okay, so let me copy this particular output what I got with permissive mode and paste it over here. Say permissive. This is with respect to the permissive mode. And permissive mode with respect to the permissive mode, what I have mentioned, if data is having corrupted record or mal record, then it is going to load. It is going to load the data if error are there. Errors are there. Okay. So with respect to data format, so the JSON file format is having certain error and it has done nothing. It has just loaded whatever the data is there in players.json. It has done nothing. Now,
So
what is
here
happening
errors
with
are
respect
these.
to
It is showing at player ID like this. This is error.
these are the format related error, corrupted records. These are
Right.
corrupted records. Okay. So what is there with respect to fail first? So fail first, what it is going to do, like if errors are there,
It will not
it is
report the
going
errors.
to what?
It is not importing data.
It is not going to perform operation. Okay. If errors are there, then job will be failed with no
Right.
message. Job will be failed.
Yeah.
Okay.
Yes.
Okay. And okay. So job has been failed. Failed fast. If errors are there, job will be failed. Now drop malformed. Drop malformed. Formed. So what is happening with drop malformed? It is going to drop the records with error and list the remaining one. So in this particular data set, what we are having, these particular records are having certain errors. So it is going to drop these particular records. Just have a look. Okay. This is the outcome with respect to drop malformed. It has dropped the records with error. So these like records, if you are able to see what we are having, this is the JSON data set, players data set in JSON format, and one player ID 101, 102, 103, 104. That is fine. Now inside the, you can say over here player ID is not mentioned, and like with respect to the JSON format, like that is nothing but key and value pair. So value is not there. So if value is not there, or the value is there into the different, you can say format, like over here integer. So JSON file is having its own inbuilt schema. If like we are going to defer that particular schema, so that will be a record with error. So over here we are having missing record, over here we are having, you can say, schema deferred values. Okay, so those, that is nothing but error with respect to a file format. JSON format is having certain error, and it has the Spark is treated these particular records as a mal record. Basically, those are not making any sense, and like will not be able to perform the operations. But once we were using permissive, it has done nothing. It is going to read all the data from that particular file. If error is there, or if errors are there, or if the records or the data is error free, it is not going to bother. It is just going to list all the data set over here. It is going to load all the data. But what the drop malformed is going to perform, it is going to remove the records with error and then load that particular data. And that's what we are able to see over here. Okay, now fail first was giving errors. Okay, errors are there. If errors are there, then the job will be failed. If errors are there, then job will be failed. That is fine. Okay, and error, that is the last mode. Okay, now let me try to remove drop malform to error. That is the third, fourth, and the last mode. Stop running. That is with respect to permissive one only. This is not the correct one.
Permissive and error both are showing same method.
Mm-hmm. It should not be there. Huh? Hmm. Okay. No attribute mode. Data frame is no mode. That is not correct. Huh? Just a minute. Is there any change with respect to the mode? Huh? Read mode in PySpark. Huh? Mhm. It should not be there. Huh? Like permissive and error, those will have outcome in different way. If it is going to provide outcome in trade modes, huh? Probably over here we will be able to see. Okay, so these are three uh, fail fast error. Huh? Okay, okay. Okay, so error is not a mode. Huh? Sorry, so this is not a mode over here. Huh? So error is not available in you can say read. It is available in write. Sorry, my mistake. So drop malformed, fail first, and permissive. These are the three modes. Permissive is the default one. Okay. If like we are going to read the data with PySpark, so default is the permissive, and permissive like if error are there, it is going to list those particular error as well, load those particular error as well. Fail first, it will throw error if like the errors are there in that particular data, and it will show that errors are there because of the format and all. Let me try to show an error is there with respect to the write mode, friends. My mistake. I have like taken it, I have mentioned it. So error is there in write mode. Let me show you different write modes in PySpark. In PySpark. So Spark by example write modes. So inside the write mode, inside write modes, we are having error. Right, error if exist or error. So that is with respect to the write mode. So if like we are mentioning error, so it is not going to perform anything. And we can like mention mode over here as well. Like mode, say permissive. Mode permissive. So it will work over here as well. So that is another way how we can leverage mode. Mode permissive, it will work definitely. Mm-mm-mm-mm. Keyword as an argument. Just a minute. Option mode drop malformed. Fail first. Inside the right mode, it will take a minute. Mode is like given in this particular way only. And another way, say dot dot option mode is available. No, 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 no. Okay, so leave it. Dot option mode, and that is nothing but say permissive, fail first, and whatever. Permissive, and this one. Okay, so let me mention fail first and do this particular execution. Okay, so we are trying to see the error, what the error is given, has been given once we are leveraging the fail first, you can say data read mode. So it will throw error with respect to the format and all. Let me show you that particular error. Hmm. Hmm. Okay, so malformed records are detected in schema inference. So what it is showing, like the data set is having mall records and parse mode is utilized as fail fast. So we will be able to see that, like once we are leveraging different modes, different read modes, and what we have seen, like three modes are there. It was like my mistake, I have mentioned the error one as well. Error is not is a mode which is there inside the data write API. What I have mentioned over here, say there are three main tasks that we are going to perform with Spark, like reading the data, then processing, and then writing it. Inside the writing we are having the error mode. Like we will see like what is happening once error mode is utilized. So there is a certain confusion in my mind. Okay, I have mentioned the error one mode as well over here. So read, three modes are there. Once like we are having data, then we are going to work on to top of that particular data in order to process it. And once the processing is done, then we are going to write the data to the disk or any BI tool, or like in order to have certain machine learning algorithm or not, or other you can say stuff on to top of that particular data. So that is what with respect to you can say data like read modes, and three data read modes are there. Then the next stuff is inferring the schema. Okay, or schema definition. So like inferring schema, that is a way in order to leverage PySpark for schema definition that you are having. Second one is programmatically defining the schema, and third one is with the help of DDL string. So what I believe, like in the next session tomorrow, we are going to work on to these particular stuff, like inferring schema we have seen, programmatically define the schema, and uh, like with the help of DDL string as well we are going to leverage. So what we will be going to do, like we will take a particular data that is not having schema, and we will be going to define the schema onto top of that particular data with these particular approaches. And then we will move further with respect to the data processing phase, and we will be leveraging different you can say functionalities from the Spark side in order to process that particular data. So that's it from my side for the day. uh, if you are having any doubt, you can ask. Swati, Vandana, Rahul, Rohit, Raj Babu, any doubt, any confusion with respect to?
Sir, I need some support with the installation. Can I contact you after this?
Yes, yes, we can have discussion after this particular
Session.
session.
This particular session. Hello, sir.
Yes, Raj Babu.
Sir, the mode